question the validity of the software or have some think that maybe some of the outputs don't make sense. And so this one person was using our energy efficiency model and was evaluating the lighting in his building, and was also evaluating his office. And the RETScreen models allows you to calculate the heat impacts of lighting on your space heating and cooling. And so he said the values were totally out of range, didn't make sense. So we asked to see the file, and when we took a quick look at it, we noticed that he had put the whole heating load, lighting load for the whole building, 500 lamps in his one little cubicle office. So of course the numbers didn't make sense, and of course the heating load was much too high. Um, but this error could have been caught by paying a little attention to what the outputs are of the model, and that's something that's very important. Um, is you need to know the ballpark of your answer before you even get to it. For those of you who have used slide rules, you know what that means. You need to know where your answer already is before you get to it. Um, and it's the same thing when using any computer software or model. It's garbage in, garbage out. And so you need to know what your end result will sort of look like before you get there. So in the RETScreen version 4 energy efficiency model, we can model a whole variety of buildings. We can do residential, commercial, institutional buildings. So it can be single family homes, multi-unit apartment buildings, hospitals, schools. We can look at both new and existing facilities. We can also look at industrial plants or processes. So we can look at the whole plant, or we can look at just part of the plant, one process in that plant. With RETScreen, you don't need to do the whole building. You can do just, say, your room or your apartment in a large building. And with RETScreen, you can also do the analysis on an existing facility. So taking what is already existing and what you're proposing to do, and also look at new buildings. So starting from scratch, as it were, and saying, evaluating different proposals and different options. So all of these things can be evaluated in RETScreen. I'm going to talk a little bit about how we do energy efficiency analysis in RETScreen. And we follow a certain methodology that we sort of follow the energy. So when you want to do something useful with energy in your building, first you have to start with your fuel. So it could be electricity, it could be natural gas, could be oil. Um, in this case, we have on the left-hand side, we um, have a meter, a gas meter, I think. RETScreen considers electricity as one of the fuels. One of the reasons is we need to do a proper energy balance. And if you consider what is the fuel that lights, say, your lighting or your computer screen, it is electricity. Now that electricity is generated somehow, it may be just from the grid, and we can evaluate the fuels that do that. But in RETScreen, we do have electricity as a fuel, and that way you won't forget it as well. Next, you need to think of how your fuel is being converted into something useful. So in this case, in the middle image here, we have a water heater, water furnace that uses the natural gas and converts that to something useful, in this case, hot water. You can see here that they've insulated some of the pipes, um, and so you convert your fuel into something useful. Um, and then equally important is the end use. How is that useful product being used? So you need to consider how, in this case, their hot water is being used in the building. Now that we've understand where we get our energy from, now we can start our analysis. And it's important to start uh, in this order. So the first thing you want to do is look at that usage, and you want to minimize that as much as possible right up front. So in this case, we have a picture of a flow reductor. that you could put on a faucet, and that will have as an effect of minimizing your usage, but also minimizing everything upstream from that as well. Next, you want to, once you've minimized your usage, then you can look to maximize the efficiency of your equipment. So here we have a combustion analyzer. So you would look into your water heater, your furnace, and see if you can't increase the efficiency somehow. It may be modifying the existing equipment, it may be buying new equipment, but you want to maximize the efficiency of the system that is transforming your fuel into the useful product. The last step you want to do is then you want to optimize your supply. Once you've minimized usage and once you've maximized your the efficiency of your equipment, that's when you look to other options. How can I maybe include solar water heating systems in to either replace a portion or all of my hot water needs? And you'll notice that at the end we have an arrow pointing up because this is a cyclical analysis. So once you've optimized your supply by maybe adding renewables to your project, this has an impact on the fuel that you use. And so it's important to close the loop, as it were. Let me give you a concrete example. When I was growing up and living at my parents' house, we had an older post-World War II house that had old windows and an old furnace, and everything was original from the original house. And obviously, we were four boys growing in the house. Our heating bills were going up, and my parents were looking to um, reduce our heating bills and also waste less energy. So we had two options. One is we needed to replace the windows because they were very leaky, and we also needed to replace the furnace. So had we replaced the windows first, so had we replaced the furnace first, because it's probably an easier and cheaper option, we would have sized the furnace for the existing heat load and heat loss in our building. And then perhaps a couple of years later, we would have saved up some more money and then changed the windows. The problem is that now that we've changed the windows and we've tightened up the building, our furnace that we bought a few years before is now oversized. It's too big. It's providing too much heat for the building. And as a result, it's running at a lower efficiency than it otherwise would be. So it's important to follow these steps here on the bottom to minimize the usage. In this case, that would be to change the windows first and then maximize the efficiency, then look to changing the furnace. If you don't follow it in this order, you end up with suboptimal equipment and wasted energy, things working at less than their optimum efficiency. In the RETScreen energy efficiency model, the point isn't for you to read this slide here, but to show you that there's three sections to the energy efficiency model. Notice on top here, this is where we do the fuels and schedules. You specify your what fuels you have, so electricity, natural gas, and so on, and we'll see these later. How you run or operate your building and at what temperatures and for how long. So this is the fuels and schedules section of the RETScreen energy efficiency model. The next part, and sort of the heart of the model, is the facility characteristics. Here's where you'll be defining your equipment and what you're going to be doing to your building. You'll be defining your heating equipment, your cooling equipment, um, and maybe what lighting you're looking at, or the pumps or motors if you have an industrial facility, your building envelope, windows, roof, doors, walls, etc., etc. And we'll go look at these a little bit later. At the bottom, we have here the summary section where we summarize all the energy use and the savings. We can also do a project verification to see if we're on target with what we said we would do, and also to verify what we've said our existing bills. And then we have a benchmark section where you can enter benchmarks to see what the energy use is for particular applications. And we'll look at that later on. An important thing to note in RETScreen is that we always compare the base case versus the proposed case. So the base case is what either is already installed or what would normally be done, and the proposed case is what you're saying you're going to do. So in an existing building, the base case is what is there already, and the proposed case is what you're proposing to do. So I'm going to talk about those three key sections a little bit more now. So the fuel types, you'll see here we have a number of different fuel types: natural gas, propane, kerosene, oils, coals, biomass, and then we also have user-defined. If you have, so you can define your own fuel, um, and you can define sort of any type of biomass or farm residue or any type of fuel that you might have. You also need to specify your schedules of your building. So when it's heated, when it's cooled, your the occupancy dependent. We also have a 24/7 schedule already built in. So if a process or something is running in your building all the time, you use the 24/7. And then you can have a set back or set up temperature for unoccupied periods. The section below here shows a zoom in of this part of the model where you specify your fuels. So you'll see here that we have three different types of fuels. The default one is electricity. You can't change that. You can't change it because you can see that some of these cells are in yellow, in white. The yellow cells you can change. You can change the price of electricity. Next, we have here natural gas, and we've specified in cubic meters. RETScreen allows you to choose the units that you want. So we have um, cubic feet, and we have therms, and we have million BTU. And we have another fuel here of biomass. The next section in RETScreen is the facility characteristics. This is where you specify what you're doing to your building. So you'll see here that we have the first two are the heating system and the cooling system. So here's where you define your furnaces, your boilers. The cooling system is where you define your heat pumps or your air conditioning system, your chillers, your desiccant heating systems. If you're doing building envelope or ventilation systems, you need to specify how your building's operated so it knows when to and how to heat and cool your building. Then you can specify the lights, electrical equipment, hot water. So I mentioned before the hot water in a building, and we'll look at an example more closely later about hot water. Pumps, fans, and motors, and these are similar tools. You'll see here that in the RETScreen software they are little hyperlinks, and you click on them. So if I click this hyperlink pumps, you get the form that pops up. And here's an example of what one of the energy efficiency forms look like. This one's the pumps. The first thing you'll see is up top we have the place to put up to 5 different pumps. These are 5 different types of pumps. So if you have an application where you have many pumps, you can group them together in 5 different types of pumps, and I'll show that to you in a moment. Next, we describe it, we give it a name, and then you'll see here the key thing that I want to show in this form is that we have 2 columns. We have base case and proposed case, and all the cells need to be filled in order for RETScreen to calculate something. So here our base case is the pumps as they are now, and the proposed case is what we're saying we're going to do. You'll see here that there's different types of cells. There's yellow cells and there's white cells. Yellow cells are cells that you enter data for, and white cells are calculated cells. So the first thing we would do in this is we would specify the motor. So we're changing from a standard efficiency motor to an energy efficient motor that have similar capacities. And RETScreen actually automatically calculates the efficiency at full load for each of these types. Now they're yellow cells, so you can change those if you know um, the curves of your motors. But generally, these are um, good to start with. We specified our load factor, and then RETScreen calculates some parameters for this motor. Next, we specify the pump that's attached to that motor and its efficiency. So not only have we changed from a standard efficiency to an energy efficient motor, but we've also changed from a throttling pump control type to variable speed. And you'll see at the bottom, RETScreen calculates that this saves us uh, 40% of the electricity needed to run this pump. Now these changes, we need to specify the costs. You'll notice the costs are only in the proposed case column because we're proposing to do something. So how much will this cost to change this motor from an energy efficient motor and the pump from throttling to variable speed? This pump change would cost $20,000. And you'll see here that we only have one of these pumps. If we have several of them, you enter the number here. You'll also see at the bottom of the form that the inefficiencies of our equipment generate heat. And if this pump is in a room or a building that is heated or cooled, we can calculate the heating impact and the cooling impact. So in this case, we put no. Maybe this pump is in a warehouse or outdoors or something. But if we do click yes, it would calculate in RETScreen automatically the effects of the heating and cooling demand on our building. So these are good things to keep in mind. And the best way to go through a form in RETScreen is to go just across and fill in all the cells and as a starting point. And I'll show that to you when we get in the software in a couple of moments. We have some more facility characteristics. These are more of an industrial nature that you would find more in industrial processes. We have process heat and process electricity. We have process steam, where we do all the steam calculations for you. So for those of you who um, don't like looking in your steam tables in your engineering books, like so many of us, you can. We also calculate steam losses. We have a couple ways you can do that. You can measure the plume or the crack or just enter it directly. There's huge benefits to be had by stemming steam losses in industrial processes. We have heat recovery, and I'll show that to you in a second. Compressed air systems, refrigeration systems, and then other. We have other here for anything that doesn't fit. If you want to, say, put a renewable energy system, say a photovoltaics, you can put them in other. Um, and you can also put very complex systems and sort of lump them together as other. So it allows you to be very, very flexible and really your imagination is the limit to what you can do with this tool. I'm going to look now at the heat recovery form. So here I've opened it up. You see you might not be able to see everything, but the point that I want to show is it looks a little bit different than the other form. You'll see here that 3 of the 5 potential heat recovery systems have been selected. Um, and we're on the third one right now. So they turn yellow when you have data entered in one of them. So here we've called this just our heat exchanger. And then we have different methods. You can just simply input the energy that you're going to transfer from one stream to the other. Or you can specify the 2 different streams. So steam to steam, steam to water, or water to water for your heat recovery system. And we also have this other to other. So if you're in the food industry and say you're looking at milk or yogurt or other products that have specific densities and heat capacities, you can enter that here. You'll notice that we only have the proposed case in this one because the base case is not doing heat recovery at all. Here we specify what our first stream is, so how often it's operating, its flow, and its temperature. And then we specify the second stream and our heat recovery efficiency, and RETScreen calculates how much heat is recovered from that. We specify how much this heat recovery system will cost us, and then we specify where we want to put this heat recovered. So you can extract the heat from a system and put that into a stream that requires heat to preheat a system. But you can also do the opposite and cool a stream. And so you can specify heating, cooling, or both of them. And RETScreen will calculate how much energy is transferred to each stream. And these are calculated in the rest of the model. So that's the second part of the energy efficiency model in RETScreen. And the last part, as I mentioned, is the summary section. In the summary section, we do a detailed fuel summary where we say how much of each fuel you've saved, how much you used in the base case, and how much you used in the proposed case. And we have a summary of that. We do a project verification. As I mentioned before, you can specify um, how much say your utility bill is currently and compare that to what RETScreen has predicted. And also, say a year later after you've implemented the project, you can go back and look at what RETScreen said you should save and what you actually did, and you can verify the project there and troubleshoot or go back to the consultants and say, you know, what happened or good job or whatever. The last section in the summary section is a benchmark tool. The benchmark tool is down here. You'll see you specify the energy unit reference and what you're benchmarking against. And RETScreen will calculate for both the base case and the proposed case for all the systems, the heating, cooling, and electricity systems, um, what those are in the units you've specified. So here we've said kilowatt hours per square meter, um, but it could be anything. If you were doing an apartment, you could say per person. In industry, you could have it per industrial output. Um, really, the sky's the limit. You can specify your own reference unit. And this is useful if you're trying to benchmark according to industrial standard practices or building codes or something like that. Once you've done your energy efficiency analysis, you can do your emission analysis and your financial analysis. Now, we discussed these 2 weeks ago in the previous RETScreen webinar, so you can look at that on the web for a more detailed discussion. Remember, RETScreen has two different methods, Method 1 and Method 2. Method 1 requires little input, and Method 2 requires much more input. So they're same degree of accuracy, but it depends how much data you want to have and how flexible you want to be. And both of these are in the model. But the energy efficiency model remains the same regardless of the method. Method 1 and Method 2, you still go through all the steps that we just went through and we'll be seeing in just an instant. But the energy emission analysis and financial analysis, they require more detail in Method 2. There's Method 1, they're a little more straightforward. RETScreen has a project database. Again, I mentioned this last week. I went through it quite a bit, so I won't spend too much time. But just quickly, RETScreen has templates. Templates are sort of quick summaries of existing that allow you to quickly get data into your software. They're sort of quick starts, if you will. Case studies are real projects somewhere built in the world, and we and third parties have documented it and made that available to you, and then you can load that case study directly within the software. So this is very useful if you want to see how to use RETScreen for particular applications. We have over 120 and we're continually adding more case studies. And user defined is where you save your projects. So you no longer need to save RETScreen as an Excel file. You can and should save it as a RETScreen file, which you can access here in the user defined tab. And remember that with just like here in the templates where we have several projects in the same file, in your user defined, you can have several different types of projects, or you can have a history of your projects in the one file. So in one file, you can save many different projects. So now we're going to jump into the software. We're going to look at a hot water example. I live in Montreal, and I live in an apartment building. And there's I, my building is similar to this. I have about 40 units in my building, and I know that it's an older building and quite inefficient. And I would like to propose to my landlord that they do some energy efficiency measures on the hot water system. So I'm proposing, I know that the faucets are old, they haven't been uh, updated in many, many, many years. And so I'm proposing that we can reduce the flow by 35% maybe. We'll reduce the temperature a bit. We'll add a heat recovery system. We pay for water, so by reducing the flow, we'll save some money on the for what it costs for water. And we'll look to see if it's worthwhile to switch from the oil-fired hot water system to a natural gas system. And this new natural gas water heater that's more efficient is projected to cost $40,000. So I'm going to open the software right now, show you it on my computer screen. Can everyone see my screen?
Yet, Kevin, so please wait a moment
I presume
for the
so.
system. Yeah,
Okay,
well, let the system catch up a moment.
maybe I'll, let's see. Now can you see my screen?
Now we can see you, so please proceed.
Okay, great. So here is the start page that you first get when you open the RETScreen uh, software. And you'll see here the first link I have is C Project Database. So I want to do a hot water energy efficiency system. So I know that there's a template in RETScreen that will allow me to quickly get some data up into the model so I don't have to start from scratch. So you should do this when you start your projects as well, is first consult the project database to see what's already there and if that can't help you. So I have the project database in front of me. This is very similar to the screen we just saw. And you'll see that we have all these templates, and you can sort them by project type, the type of building that they're in or the equipment that they use, or the name. And you'll also see that we have all these case studies. We have, like I said, over 120, and user defined as well, which I won't go into yet, but I'll show that to you in a moment. So I'm looking for energy efficiency measures. I know that there's this hot water in an apartment building, which sounds very much like the project that we want to analyze together. So I can select that if I click on this yellow, if I click on this help button at the bottom here, the help system in RETScreen opens, and you'll see it's a description of basically what I described to you just moments ago. So I'm going to click on the OK button, or I can double click on this to load it into RETScreen. I've made some changes before and I don't want to save those. And here the software is already pre-filled with some of this data. So you'll see here we have some gray cells that are just for information. We've selected that we're doing an energy efficiency measure in a residential building. Method 1 because I don't want to get too complex. And uh, down below here, I mentioned that I live in Montreal, so I'm going to uh, select Montreal data. So by default, it's in Ottawa, because RETScreen is developed by the Government of Canada with Natural Resources Canada, with our partners. So we have Ottawa. So here's our climate database. You'll see that we have countries all over the world, and we have provinces here in Canada, and Montreal is in the province of Quebec. So selecting here the data. You'll see here that I can choose the units, so I'm comfortable in these units. So I'll leave them as they are, and this is the data that is in the RETScreen climate database. And we discussed this again 2 weeks ago, so you can see uh, the webinar from 2 weeks ago to get more uh, familiar with this climate database. When I'm happy with this, I click on this button, and that data is automatically pasted in here. If I want to change any of it, I can. So suppose I know that uh, where I live, it's not minus 10.3 in Montreal, it's actually minus 10.2. I can do that. So we get many questions of people asking us how they can put their own data in. And it's simple, you just type it directly within the cell. I'm going to hide this now because I don't need it anymore. So that rolls up. And now I'm ready to do my hot water system. So I'm going to click on this link here, Complete Energy Model Sheet, and we get to the RETScreen model here. Now it might be a little bit small on your screen, so I'm going to zoom in, but before I do that, notice that there's 3 sections. This first section here, fuels and schedules, like we said before. The second section, facility characteristics. And the third section, the summary. And then below that we have the emission analysis and the financial analysis like we discussed previously. So I'm going to zoom in so that we can see a little bit better here. You'll see that this project has electricity, as we mentioned before, already by default. In Quebec, we pay about that, 10 cents a kilowatt hour. And this is actually what I want. We are going to be looking to change from an oil-fired hot water system to a natural gas system. Oil is probably a little more expensive than that where I live. Let's say 95, although I'm not exactly sure. And natural gas, that sounds about right, but let's be maybe a little conservative and price. Now you can change this for where your project is, of course. So after this webinar, I encourage you to open up the software. Not now, so it's better to follow along now, but afterwards, open up the software and do exactly this this sample on your own building or on your own house or your own office. And that's the best way to learn and with RETScreen is to open it and just do something. So we finished the fuels now. The next thing is we have schedules. We don't really need to put that in. You only need to use the schedules if you're doing looking at heating your building or have a ventilation system. So in our case, we are only looking at that hot water portion. So remember before at the first slide I mentioned that in RETScreen you can do a whole building or you can do just part of a building. You can do a whole plant or just one process. So I'm not required to look at the whole apartment building. I can just look at the hot water uh, measures for my building. Nevertheless, here I've said that the building is heated to 22 degrees is set point and 22 degrees cooling, and that's set 24/7. And I'll leave that as is. You'll see also that we have a changeover temperature that specifies the length of the heating and cooling season. Again, these are used only when you have you're looking at the building envelope to heat or cool your building or a ventilation system. I'm moving down now, and here is the facility characteristics. So this is the core, if you will, of the RETScreen energy efficiency model. So the first thing to do is to specify a heating system. So I'll click on this hyperlink here that says heating system, and I get this window that pops up. You'll see here that already one system is defined. It's called boiler. And I need to fill in now the base case and the proposed case. So the base case, I need to choose what fuel it's using, and I said it was an oil-fired boiler at about 65% seasonal efficiency. That sounds good to me to start off. And I'm proposing to change to a natural gas-fired boiler, a water heater, at about 80% efficiency. That sounds good. Now, are these reasonable figures, 65 and 80%? I don't know. So what we can do is by having this cell selected and then clicking on the Help button in the bottom here, I can open the RETScreen Help, and you'll see here we have a short description of this form and what it requires. And I have here seasonal efficiency as one of the entries in that form, and I'll click on it. And we describe here in this in the RETScreen Help what it is. So it says typical values are what this is, and it says here that we can look at this table. So I'm going to click on this table, and we'll see here that um, if we have a standard efficiency, I know that the one that we have in our apartment building right now is not a mid or high efficiency, and it says the typical annual heating system seasonal efficiency is 55 to 60%. So we have 65, so I'll leave that as is. Remember, this is the seasonal efficiency, so it's over all seasons. It includes standby, it includes on-off switching. Um, so this is, I'm going to leave these values as is. I think I mentioned that the furnace is about $40,000 for this building, so I'm going to leave that. And here are the incremental operation and maintenance, or O&M savings. Notice that they're just in the proposed case. So we're asking, by implementing this new furnace, what are the savings that you'll have? So it may require less maintenance, and here we're estimating that it'll cost $1,000 less per year to operate this new furnace as compared to the old uh, oil-fired water heating system. So if I'm happy with this, I can click on the OK button. If I want to completely erase this, I can click the Erase button. And if I just want to exit without committing any changes, I can click this No button or Cancel. But I'm happy with this, so I'm going to click OK. And the data is here. So you'll see boiler, and it says here has some summary. And I'll get back to this in a second. The next thing we want to look at is our hot water system. So I'm going to click on this hot water hyperlink here um, to open the hot water energy efficiency form. So I'm going to do that, and I'm going to change this quickly. You'll see again here I only have one hot water system, but suppose this was a very big building, or there was two different types of hot water heaters in the building. I could put a second one. See, it's blank, and now I need to enter the data, a third, and even a fourth and a fifth. But my building only has one, so I'm going to return to this one. So the first thing we're asked is, what is the hot water use per day? So does anyone know, some of you probably do, what the hot water use is for a 40-unit apartment building? The key is that it depends. Depends what your units are, depends who's in the building. So we have this little calculator here in RETScreen called load type. If I click on it, you'll see here that we have this drop down where we have different building types, different unit types. So from restaurants and laundromats to car washes to apartments to hospitals. So I live in an apartment. I said there's 40 units, and it's always occupied. It's always fully rented out. And RETScreen here estimates that this is 6,778 liters per day. Now this, what we're doing behind here is we have a table from ASHRAE, I believe, and we're instead of looking it up, you can calculate it right here. So instead of having all your books open and always looking up these tables, we have it here just right under your fingertips. So is this a good value for my building? Well, actually, in my building, there's a lot of young families, and I know there's a lot of kids in the building. So I think that it's probably closer to 10,000 liters per day in my 40-unit apartment building. Now, I was going to implement flow reductors at 35%. So 35% reduction from 10,000 is 6,500. So this is the proposed case. So base case 10,000, and I'm proposing to put it at 6,500. The temperature right now is very hot, and I'm proposing to reduce that temperature by 5 degrees. Now, what is RETScreen actually doing? It's taking this water, 10,000 liters per day, and it needs to heat it up to 65 degrees Celsius. But heat it up from what? Well, from the mains of the city, from the inlet temperature to the building. So does anyone know what the inlet temperature of cold water is in the city of Montreal? Probably not. Probably no one here knows. I don't even know. Um, so what we have here is a formula. So if I click on formula in the supply temperature method, RETScreen will calculate the minimum and the maximum temperature uh, in Montreal for that. What we do is, remember on the start sheet we selected the climate data. RETScreen takes that data and uses that to calculate the minimum and the maximum water temperature. And this is actually uh, very correct for Montreal where I live, so I'm going to leave that. If, however, you know exactly your temperatures or you want to uh, use your own temperatures, suppose it's preheated or something, you can specify your own by using user defined. But I'm going to leave it on this formula method. Next, we ask how often this water is available. I know that it's available 24 hours a day, so I leave it here. Um, and then I ask if we have any heat recovery. In the base case, no, we have no heat recovery, so it's 0% efficient. And I'm proposing that we put in a 20% efficient heat recovery system. And that system is going to cost $15,000. And I'm also uh, suggesting that I will save about $3,000 in operation or maintenance, or in this case, water cost. Remember, I've reduced the flow of the water, and as a result, I don't have to pay as much for water. And I can estimate that this 3,500 liters per day of savings will cost me over the year, will save me over the year $3,000. Next, I need to specify what system is heating this water in the base case and the proposed case. So in the base case, it's my boiler. In the proposed case, it's the same heating system. Remember that this heating system has changed from the base case to the proposed case, but it's still the same heating system. So in this case, it would be oil, and in this case, natural gas. RETScreen then calculates um, the heating required to heat the water from the inlet temperature to the desired temperature. So in the base case, it would require 251 megawatt hours of heating, and in this case 119, or I've saved over half of the energy to heat the water using these measures. So if I'm happy with that, I can click on the OK button here, and it will paste that into RETScreen. Pasted, and now we have this data right here. And you'll see here now, I'll talk a little bit about this table, what it shows. So you'll see here that we divide the energy into heating, cooling, or electricity. And you can choose the units as well, from megawatt hours, gigajoules, or million BTU. Let's leave it in gigajoules for now. And you'll see that the boiler, remember what I did is I changed from an inefficient oil-fired boiler to a more efficient natural gas-fired boiler, and that saves 260 gigajoules of heating fuel. And by reducing the temperature, reducing the flow, and putting in a heat recovery system, I can save 591 gigajoules of heating on the hot water system. And RETScreen divides them up properly and gives you the sum here that shows that in total we can save 851 gigajoules of fuel. Now the reason I say fuel is because here we can decide what we want to see in this table. So I can see how much fuel I consume in the base case. So in the base case we consume this many gigajoules of fuel, or the proposed case, or saved. And we can also look at it on an energy side. So we can look at the energy saved. Leave it on the fuel saved. And now I'll move over to the right a little bit so that we can look at the rest of this table. Here we have a summary of the costs for each measure, and the fuel savings, and then the operation and maintenance savings. And then we provide a quick calculation of the simple payback for each measure. So switching the furnace and switching the fuel allowed us to have a payback of 4.2 years, and um, reducing the temperature and the water flow with a heat recovery system um, has a payback of less than 1 year. And in total, all this measure would cost us $55,000 with a payback of 1.71 years. You'll see we have this last column here that says include measure. So we can decide whether we want to do these measures or not. So suppose we decided what we weren't going to reduce the water temperature, or we weren't going to reduce the water temperature or put in the flow restrictors. We were just going to replace the furnace because that was the most critical. So we click that, and because we don't want to include that measure. And look what's happened now is that our simple payback has been reduced to 1.8 years um, for that measure. But this is a bit misleading, because remember the first slide that I mentioned, um, where one of the first slides where I mentioned the order of the steps of things to do. And the first thing to do is to reduce your consumption, then increase efficiency. This measure here, the hot water system, is reducing the consumption. The next is increasing the efficiency. It's important to do them in this order, because otherwise your heating system isn't as efficient as it could be and will be oversized. So I'm going to continue on now, in moving down in RETScreen into the summary section. The summary section here, as I mentioned before, we list the different fuels. Uh, we list how much we consumed in the base case. So in the base case, we used 36,000 liters of diesel at a cost of $34,000. And in the proposed case, we use 14,000 cubic meters, or about $6,000 of natural gas. And then we have a fuel cost savings here of $28,000 savings just of the fuel. You'll also see below here that I have the project verification. I mentioned this before. So suppose I print this up and I go to my landlord and I say, I think that this is something good to do in our building. And so together he and I can pull out uh, the old oil bills, and he can tell me, well, Kevin, actually last year we only used 33,000 liters of oil, and we see here that RETScreen said in the base case, this is our oil system, a difference of 9%. So what does that mean? Well, let's think of some of the things that we had to assume or guess. And one of the things was the efficiency of our system. So um, maybe my boiler system was not 65%, maybe it was 68% efficient. So I click that, I change that. You see, I'm getting a little closer now. And so you can iterate like this until you sort of reflect reality. Similarly, what I can do is I can say a year later, suppose we do decide to implement this, and a year later we look at our natural gas bills. I sit down with the landlord, and he says, Kevin, last year we had 13, we were billed for 13,500 um, cubic meters of natural gas, and RETScreen predicted uh, this much. So we actually did better. We used less than what we proposed. So this is a way for you to verify the actual savings. In the future, we'll be developing a tool that will allow you to do this in much more detail. But that's coming quite a bit later. Next, we have an energy breakdown, as I mentioned, for the heating, cooling, and electricity systems. And like before, we can look at either energy or fuel. And then a benchmark. So suppose that in Montreal, they're trying to reduce the energy footprint of apartment buildings, and they are looking to uh, look. They're looking to have a certain limit. So my landlord and I, we can look at what that limit is. So I can specify, say it's per megawatts per cubic or per square meter of floor area. So I know that, say, uh, actually, I know my apartment size in square feet. So I'll say there's 40 units, and say it's about 850 square feet. And now RETScreen calculates this here. So RETScreen calculates the energy in the base case and the proposed case, and how much energy was saved in the units you specify. Suppose that instead I want to say it was, say, a hospital. You can put it per bed. Um, Here's where I mentioned before, you can say user defined. So I can say in this apartment there are 40 units and there's 3 people per apartment. So I can say maybe um, it's 40 units times 3 people, so there's 120 people in the building. So previously, each of us was using just over 2 megawatt hours per person, and now it's just under 1. So a savings of just over 1 megawatt hour per person. As I mentioned before, the rest of the model is the same as what we showed 2 weeks ago, the emission analysis and the financial analysis, so I won't go through those now. But because you can look at those on the webinar that was saved. So that's a very quick rundown of what you can do in RETScreen. I'll show 2 other things quickly before we go to the Q&A session. One is that if I go to the um, first thing, I'm going to save this to a RETScreen document. 2 weeks ago, we saved a our RETScreen projects in a file I called Leonardo Webinar Example. So I'm going to save this project there. I'm going to show you something a little more complex. Um, I'm going to click on User Defined, and you'll see I can open up uh, our our examples that we had from last week. So 2 of these are things that we did last week or 2 weeks ago, and this is the one we just did today. But I'm actually interested in something. Um, oh, here it is. This is an industrial application, and I just want to show you how complex this can get, how detailed you can get. So I'm back on the energy model sheet, and you'll see here that I have many different measures doing many different things. I have a building envelope. I'm looking at the lighting. I have electrical equipment, my hot water. I have 2 different types of motors in this building, 30 and 10 horsepower. I also have a compressor system, a cooling system. Um, so the model could get quite detailed, and sort of, as I mentioned before, the sky's the limit when you want to evaluate your projects. And then, of course, like everything in RETScreen, version 4 now is translated into 30 languages. So if you're working with someone who speaks a different language than you, I know right now we've had over 60 people in this webinar, so certainly some of us speak languages other than English. Um, Perhaps there's some people here from, say, China. So if we were doing this apartment building that I did before for an apartment building in China, I can switch it, and here's all the forms, as we saw before, translated automatically. And you get all these languages when you download the software. You don't need to download separate language packs or anything. So you can save this file as a .ret file, as we did before, and send it off quickly by email, and you can collaborate easily on your energy efficiency projects that way. So let's go to the Q&A session. I'm open to, I'll show you any other parts of the software you want, and that's it for the presentation.